Working memory. The brain. It's one of the most confusing parts of the human body. Take a moment and consider what the brain does. Go on, what does the brain do? If one of your first answers was memory, this is the video for you. There are several subcategories of memory. You probably know about long-term and short-term memory. But there's a third one, called working memory. While your brain may not actually be juggling and riding a unicycle through water, it does have to combine many things at once in working memory. Working memory lets you manipulate information. It allows you to hear what I'm saying, see this video, process the information, and then do something about it. See, short-term memory stores just a few pieces of information for a couple seconds without processing any of the information, and then it's gone. Working memory also has a limited capacity, but working memory allows you to do something with the information presented. There's a couple ideas of what is actually going on in working memory. However, this video will focus specifically on Baddeley's model. Baddeley's model, first introduced in 1974, says that there are four components to working memory. First is the phonological loop. Second is the visual-spatial sketchpad. Third is the central executive. Fourth is the episodic buffer. These components act together to process information and connect it to long-term memory. Let's take a closer look at the individual components of Baddeley's model. First is the phonological loop. This stores any auditory information in your surroundings. Right now, you're listening to this video. What I'm saying is currently being stored in the phonological loop so that you can understand what I'm about to say. The phonological loop repeats information so that you remember it for the moment. It's like rehearsing the name of someone you're about to meet for a blind date and you don't want to forget their name. According to Na et al. 2000, the phonological loop appears to be in the inferior frontal cortex, inferior parietal cortex, and temporal gyrus, especially in the left hemisphere, which are also the language centers. The next component is the visual-spatial sketchpad. This lets you see things in your mind's eye. If you close your eyes, you can probably picture what was just on the screen. Or if I show you this picture of a panda from Zoo Berlin, can you look at it, close your eyes, and then picture it with pink fur instead of white? Your visual-spatial sketchpad is what allows you to hold an image in your mind and manipulate it. It's what's letting you see and remember this video right now. This also helps you to see where something is. How far away is that pencil? What about that spiral on the notebook? This information is processed starting at your visual-spatial sketchpad. The visual-spatial sketchpad appears to be primarily in the prefrontal and superior parietal cortices, according to Na et al. 2000. Third is the central executive. This is the command center of it all. Here, the information from the phonological loop and the visual-spatial sketchpad are brought together. The central executive also helps choose what we bring our attention to. For example, you can currently see your nose and probably hear an air conditioner or people walking in the halls. However, your brain does not pay attention to the fact that you can always see your nose or hear air conditioners or people walking. The central executive chooses what you actually pay attention to. According to Eriksson et al. 2015, the central executive includes the prefrontal cortex, the superior parietal cortex. The central executive does one more thing. It helps the episodic buffer transfer relevant information to the long-term memory. So this brings us to the episodic buffer. This is the newest part of Baddeley's model, only incorporated into the model in the year 2000. The episodic buffer is important because it helps transfer information to long-term memory. Once the information from the visual-spatial sketchpad and the phonological loop have been directed to the central executive, the information is sent through the episodic buffer to be transferred into long-term memory. It also seems to help sequence information so that it's put in chronological order. This way, a sentence like, "The dog jumped over the fence and then ate a steak," doesn't become, "The dog ate the steak and jumped over a fence." The episodic buffer may also be involved in semantic memory, but this is not as well understood. The episodic buffer has been commonly associated with the hippocampus. However, Baddeley recently argued that there are likely several other areas associated with the episodic buffer that researchers have not yet identified. Well, this brings us to the conclusion of an introduction to working memory. Now you understand the brain regions involved in working memory, what each of the 4 parts of working memory do, and examples of each one. So next time you're sitting in lecture, at home studying, or maybe just driving down the street, be sure to engage all of your working memory and thank your brain for its complex coordinating.